All right, guys, we're jumping into our last topic of the year, and it's actually going to be a pretty quick one. Only a couple days. We're not going to have time to get too deep into it, but I wanted to give you just a little bit of an idea of kind of what solids are all about. We spent a lot of time talking about two-dimensional shapes. We've done, triangles and polygons, and think of all the things we've done this year. But we haven't done anything in 3 dimensions, okay? And that is exactly what a solid is, okay? A solid, right, is a type of geometric shape with 3 dimensions. So the dimensions are length, width, okay, and height. Okay, length, width, and height. So examples of solids could be a cube, maybe. Could be a pyramid. Okay, could be a prism. Could be a sphere. Oops, sphere does not go S-H. S-P-H-E-R-E. Okay, there are others ones too. Those are some of the most common ones and ones we'll be seeing. All right, so I want to jump just right into them. So let's start with rectangular solids and cubes. A rectangular solid, okay, is pretty similar to a cube. Okay, it's got rectangular faces, and when we talk about faces, we're really just talking about sides. So it's got rectangular faces, and a cube is a rectangular solid, okay, with square faces. Okay, so square faces. So you can imagine all the 4 sides are squares, and then their bases, or what we call the faces on each side, are squares. Okay, so the way we calculate the volume of a rectangular solid is pretty simple. Given length times width times height, or you could think of it as the base times the height. And the base, when I say B, I mean area of the base. Okay, so area of the base of my rectangular solid. Okay, and actually, never mind, we'll come back to that later. All right, so that's pretty much all we need to know. So it says find the volume of a rectangular solid with a length of 4 inches, width of 3 inches, and a height of 11. All right, so here is, again, one of the ways we can, think about this. Is it's just length times width times height. So all we need to do is just do 11 times 3 times 4, okay, and that gives us 132 inches cubed. Okay. Problem 2. The volume of a cube is 216 inches cubed. We know cubed has all square faces from above. So all we really need to do, since we know this is a cube, I'm just going to draw this out. If I have a cube, let's see how good my drawing skills are. Right. And every side of that cube is x. So we know x cubed equals 216. So to find the height, which would also be the width, which would also be the length, we just need to take the cube root of both sides, and I would get x is equal to 6 inches. Okay. Number 3, I'm going to let you do number 3 for homework. Okay, I'm going to just start circling all the homework problems that we're going to do in red. So that's a homework problem. I'll post the solutions on Canvas, but give that one a shot. Let's move into prisms, okay? So a prism is a solid. Change of colors. Prism is a solid with a polygonal, or with polygonal identical parallel bases and sides lateral faces that are parallelograms. Okay, a right prism is where the lateral faces and bases meet at a 90-degree angle. So if we look at these shapes right here, here would be a good example, of a prism. And in this case, if we assume these are right angles up here and all that stuff, right, that would also be a rectangular solid. Okay, but this one looks to be a right prism. This one right here is not a right prism. This one is a right prism, right? That the bases, we have parallel bases, that meet at a 90-degree angle. Okay, so there's some examples of right versus non-right prisms. Okay, an altitude, we've talked about altitudes many times this year. An altitude of a prism is a segment joining the two bases at, okay, a 90-degree or right angle. So you might be saying, well, how can you find an altitude in that middle one? Seems pretty obvious what's in a right one. Well, if we were to draw an altitude down, imagine this base here extending that way, so that the base is still coming out here. Altitude would give you the height of that prism there, right? So the altitudes will be helpful when we're calculating the area, or not the area, the volume of a prism, because the volume of a prism is the exact same as rectangular solid, in that the volume is equal to the base area of the base times the height. Now you might have to calculate that height though. Okay, you might have to calculate that height. Okay, but again, when we talk about big B, we're talking about area, okay, of that base. So we look at the next one. It says, find the volume of the prism below. Well, let's do a little work here first. Right, we have a right angle there. That's 3, so I know that's 3. If this piece here is 6, the entire length is 14, right? Then this must be 4 and 4. Okay. So I think the easiest thing to do is maybe break this down into some triangles to help find the area of that top base. So it would be what? Well, 6 times 3 would be, let me color it in. 6 times 3 would give me the area, that part of the area of the base. So 6 times 3 equals 18. And then those two triangles, it would be 2 times 1/2, which I know will cancel, times 4 times 3. That's going to give me 12. So the area of the base, right, that would be your B value, is 30. So the area would be 30 times the height, which in this case is 5, which would be 150. Do we have units here? We do. Centimeters cubed. Don't forget we are cubed here. All right, so it says find the volume of the prism below. Okay, the two parallel bases do not meet at a right angle, but what we are given is the altitude, which is this length of 8 here. There's the altitude of 8, and it looks like we have some right triangles as the base. So if we try to find the area of the base, 1/2, right? 5 times 9, that's going to give me 22 and 1/2. And then to find the volume, oh, I noticed above I have A. I'm so used to writing area. Volume equals 150 centimeters cubed. The volume would be equal to, right, 22 and 1/2 times 8, which is the height, which is 180 meters cubed. Okay. Next problem, all 9 inches, blah, blah, blah. Good homework problem. Okay, that's a little bit of a trickier one, so be careful with that. I think you guys can handle it though, but a little bit tricky. Pyramids, okay. Pyramid, let's get into those. A pyramid is a solid with a polygon as a base. Okay, with polygon as a base and whose sides are triangles. Triangles and meet at a point called the apex. You would have heard that in just kind of everyday life. The apex of something is like the top, right? And usually the apex in a pyramid would be the top of the pyramid, right? So the base of the pyramid can be all kinds of shapes. If we look at some of the diagrams below, we've got a rectangular pyramid. Those are the ones you see in Egypt, I think. I've never been to Egypt. I don't think they're triangular. I think they're rectangular. We have hexagonal pyramids. We have heptagonal pyramids. We have decagonal pyramids. You really could have an infinite amount of pyramids and sides. So the volume of a pyramid is given, okay, a little bit more tricky than before, but not too much. 1/3 of the base times the height. And again, B is area of base, capital B. Okay. So let's take a look at a few examples here. So we've got this pyramid below. It says find the volume of the pyramid. Volume, pretty simple when you're given all the information. It's the area of the base. So volume equals, what's the area of the base? 1/2 times 4 times 6, right? Times height, which is 9. Oops, I forgot the 1/3 piece. There should be a 1/3. 1/3 times 1/2 times 4 times 6 times 9. Do all that math out. 36 meters cubed. Let's take a look at number 2. Originally, the pyramid had a height of, this is Khafre's pyramid in Egypt. The pyramid had a height of 144 meters and a volume of 2,226,450 cubic meters. Find the side of the length of the square base. Well, here's what we know, right? We know that volume of a pyramid is 1/3 base times the height. It's a square base, so that's good to know. Had a height of 144 meters and is a volume of 2,226,450. It's going to be equal to 1/3 base times a height of 144. If we simplify this, right, simplify this a little bit, we get B, I'm just going to move it to the left side, equals 46,384,375 meters. In order to find the length of a side, we need to take the square root of that. So if you take the square root of both sides, a side is approximately 215.37 meters. That's a big pyramid. Okay. So if we look at the next one, find the volume of the pyramid below. Ooh, you'll need to use trig. I don't want to spoil the fun for you. Let's assign that one for homework as well. So you got 3 problems you need to do. Yeah, a little bit of trig here. Make sure you have your calculator handy. Guys, there's not too many tricks to this. We don't really have time to get into too deep of stuff, but I do want you to see it. Okay, I do want you to see it. So take a look at this and do those 3 problems for homework, and then we will discuss them next class.